So what me and Mr. Bodley decided was we took everything that we originally wanted to teach you about dilations and we cut out everything we thought that wasn't extremely important for you to be prepared for the 9th grade and for high school. So we have like the bare bones, everything you need to know about dilation. And we feel like at this point, we've presented it all to you. So today we're gonna practice so that we can be ready for tomorrow's little assessment. Taylor, thank you for typing that in. I did not know that. So I want to talk first about the word dilation, and I'm going to write it up here. And if I were you right now, I would grab a sheet of paper because tomorrow during the test, I want you to use this sheet of paper to help you. Oh my gosh, I never tell you to cheat. It's not called cheating. It's called using your notes.
Which
right now, we're going to make some of that. All right. So, Kate, I muted you just for the grade topics. All right, so I'm going to put the word dilation up here. And yes, I am definitely wearing sweatpants right now. So, as we've got dilations, making sure I don't spell it wrong. Okay, so we've got dilations, and just verify with me. Can you see that forward that's written in the correct direction for you?
Yeah.
Okay, all right, so we've got dilations, and I want to talk about a couple things. One of the things that you need to know about dilations is called a scale factor. A scale factor is just what you multiply by. So scale factor is what you're multiplying by. We usually use the letter K. So what you're going to see on a lot of these things is this letter K. And K is whatever you're multiplying by. So sometimes it'll be a number like that, K equals 2. Sorry that there's a glare. I don't think there's really anything I can do about that apparently.
Oh, good.
Okay, I can like shadow it, but that's not really helping. Okay, so if K equals 2, and I had an ordered pair, like, I don't know, someone give me a number.
2.
2. Rylan, we already used the number 2. Give me a different number.
4.
6.
26.
4. I'm gonna go with 4, and I'm gonna go with -6. Okay, so I'm gonna use the scale factor K equals 2. 8th graders, I cannot emphasize how simple this next part is. If the scale factor is 2 and your ordered pair is here, you are going to get A prime by multiplying 2 times everything in the parentheses. Okay, so for A prime over here, 2 times 2, or excuse me, not 2. I'm already stuck on the number Rylan gave me. 2 times 4 is 8, and 2 times -6, -12. That's how you multiply by a scale factor. Oh man, let me see if this makes it any better. Is that worse? Nah, I don't think that's any better. Okay. So, my scale factor times everything that was in the parentheses. Now, sometimes your scale factor is a fraction. So, I need a fraction. What's a good fraction?
4/5.
4/5. That's a really tough fraction, Rylan.
1/2.
1/2. Let's go with 1/3, but yeah, is it only frozen for me? Sorry, Taylor, it might be frozen just for you. All right, I'm going with the scale factor 1/3. Now, if I have the ordered pair 4, -6, I'm using this scale factor, then I'm going to now just multiply that times these two things. Now, 4 times 1/3 is not a number that I want to actually get the final decimal for because it's going to be repeating decimal. So I'll call this A prime, but when I do 4 times 1/3, I'm actually just going to keep the fraction form. The 4 would be in the numerator over 3. Okay, when I multiply 6 times 1/3, again, it's just like doing, or -6, it's just like doing -6 divided by 3. And when I do that, I get -2. Now, if you're wondering where I got these numbers from, like you can get these numbers from a calculator. So if you can, I should ask, hopefully Oh, I'm looking there. It's kind of lagging for a couple of you. Kind of back. Rejoin if it's frozen. Good advice. So if your screen gets frozen right now, try logging out and then rejoin back in. I'm also recording this whole thing, so if you need to watch it later, I'll attach the YouTube video and you can watch the full recording again or go back to the pieces that you missed. So use a calculator, and I can link you a couple websites where you can get good calculators. I believe that if you go to desmos.com, which we've used in class a little bit, that's a fine calculator. I think if you go to TI's website, you can find a calculator pretty similar to the one we've done. Even if you just Google, what is it, just a scientific calculator. You don't need a graphing calculator. Also, your phone probably has one. If you don't have a phone, your parents' phone probably has one. And if you can't find all the things you need on your parents' phone, take the phone this way, and then, oh, I've got one with me. If you've got, let's see, I'll show you on an iPhone. Where is it? Okay, I'm gonna open up the calculator app, and not that. So I've got the calculator app here, and if my screen is unlocked, if I tilt it sideways, a bunch of extra functions show up. So if you've never used that before, it's a really helpful thing because it adds stuff like square root and exponents and other stuff like that. So again, if your calculator is this way, it's like the dumb calculator. Turn it sideways and you can get a ton of extra functions. All right, so that's our basic explanation for how to dilate something. You multiply by that scale factor on every single term. So what a lot of you saw on the quiz was it kept asking if it was similar, if it was congruent, or if it was neither. And the big idea there is when you dilate, you make it bigger or smaller. And that means it's not congruent anymore. Because if you make something bigger, if we go back to that definition of dilation, dilation means the same exact shape and the same exact size. And if it's bigger, it cannot be the same size. So that makes it similar. Similar, I'm gonna write this down. I know some of you are watching, actually I'll write it at the bottom. The word congruent, write this on your notes. Congruent is going to be same size, same shape.
What would that look as in a number?
What would that look like in a number? I'll show you an example in a second. Thanks for asking, Rylan. Similar. I'm not going to write same size because they are not the same size when they're similar. They are only the same shape. So I'm going to erase this section up here, and I'm going to show you some examples of that. So in this section, where we talked about scale factors, I'm going to get rid of that. And I'm going to show you some rules. Oh boy. This is a really crappy whiteboard. It's not even really a whiteboard, I think, because it's not like magnetic. So I'll show you a picture of two things that were congruent. So if I were to draw, I'll draw a triangle.
Alexa, stop the timer.
I don't know if you can hear that. My kid is doing a timer, apparently. So these two shapes, yeah, I know, they're not perfect because I'm not great at drawing. Let's assume that these are the exact same size, exact same shape. Those are congruent. They're congruent because they're the same size, the same shape. Now, if I were to draw similar ones over here, it's going to be the same shape. That means the same exact kind of triangle. But one of them is going to be a different size than the other. So these are an example of similar. Now, if I gave you one of the side lengths, let's say, for example, that I told you that this bottom side was 2 inches long. And then I told you that this bottom side was 8 inches long. Now, me and Mr. Bodley aren't going to test you on this tomorrow, but I want you thinking about this. What sort of scale factor would I have to use if this was A and this was A prime? How do I go from a side that's 2 inches long to a side that's 8 inches long? What do you do to go from a 2 inch long side to an 8 inch long side? You can type it in the comments if you'd like. Multiply by 4, thank you. So someone said add 6 inches, which I love that they said that. The problem with adding here though, is dilation does not add. Because when we add on these things, I'm gonna draw a little example right here. If I were to start with x comma y, and I added 6, that won't give me a dilation. If you remember from class, this is actually a translation. That would make you go to the right 6 spaces, and it would make you go up 6 spaces. So these would actually be congruent because it's just sliding it to the right and up. So adding isn't gonna help us. We would actually call this one a dilation with a scale factor of k equals 4. That's hard to see the bottom of that 4. There we go. And the reason that k equals 4 is because if we're looking at the same side, it multiplies by 4 to get from one to the other. Now, again, the reason that we know that this one came first is because it doesn't have any primes on it. The prime one comes second. All right, so this is what similar looks like in a picture. Same shape, different sizes. Now, I want to show you what it looks like in a rule. So I'm going to erase again. And again, if you didn't get that copied down, I'm going to post this later and you can skim through the video and find where you missed. Okay, so all of these start with x comma y. And you saw a couple different examples on the quizzes that you took. I showed you a bunch of examples where they were similar, and a lot of examples where they were congruent, and a lot of examples where they were neither. Here's what you're gonna see. The similar ones always multiply by the same number. I would say a times x, k times y. The reason I'm writing k is because it can be any number on the entire planet. It can be a fraction, it can be a whole number, but when the same number is multiplying by both letters, then it's going to be similar. Now, some of them did this, where they said, okay, I'm gonna multiply by x, but not by y. That's not similar, and that's also not congruent. That's just gonna be a really stretched out, weird picture. So that's gonna be an example of neither. And then the ones that are going to be congruent, you're not allowed to multiply any non-1 numbers in front of x or y. So you just have like, it could be like negative x plus 3 comma y. It can have addition, it can have subtraction, it can have negatives, but it just can't be multiplying either number for it to be congruent. Because remember, every time you multiply by a number, it stretches one way or the other. So if it stretches both of them, then that's great. It stretches across and up and down, and that makes it similar because it doesn't get distorted. But if you only stretch this way, it gets it to be like a really fat picture. If you only stretch it this way, then it's a really tall picture and they're not the same shape anymore. They're gonna be like morphed shapes. So there's our difference between similar, neither, in the middle. In the middle was congruent. Sorry, that's really poor handwriting. It looks, when I look at my screen, it's backwards, so I am trusting you all that you can actually read what I'm writing on the board right now. Okay, that was one of the things I wanted you to talk about, or wanted to talk to you about. And then there's one more thing I want to discuss before, as we're looking over what's going to be on tomorrow's test. So I'm looking at this test so that I can help you do these. Okay, I'm going to erase this whole section. And I'm also like fully on the lookout for spiders because my basement every once in a while has a spider, and I swear if I see one I will cry on camera, but I'll still post it so you can all like laugh about it. Okay,
I hate spiders.
Me too. Let's talk about this scale factor. So if we have a scale factor, and remember the letter for our scale factor is k, if that number is greater than 1. If our scale factor is bigger than the number 1, then we're going to make our picture bigger. And we call that enlargement. How do you spell enlargement? Enlargement. I think that's good enough. Okay, so if that K number is bigger than 1, then your picture is getting larger. So what do you think is going to happen if that number is smaller than 1?
Decrease.
Decrease is a good guess for the word. Ew, Taylor, that's disgusting. Pet spider in your basement. It's not actually called the word decrease. Let me see. What's the word we use? It is called...
I have a friend that has a tarantula. It's Harry Underwood.
I'm going to tell you something right now. Nobody should have a pet spider. Okay. I want a pet spider. No, you don't, William.
Oh my gosh, Kason, get out.
Ew, Taylor. Okay, anyway, you guys are disgusting. Anybody who has a pet spider, like, I'm judging you hardcore right now. Okay, so let's go back to this. If it's bigger than 1, your scale factor, it's going to get a bigger picture. If your scale factor is smaller than 1, and let me write one more thing. That means if it's a fraction, then it's going to get smaller. Okay? If it's a big number, if it's bigger than number 1, it's getting bigger. And if it's a smaller number, then it is shrinking. All right, I am going to look at another problem.
If it's enlarged, is it a whole number?
Yes. If it's enlarged, then it's going to be a number like 2 or 5 or 27 or something like that.
This has to be not like decimal.
It has to be not a decimal and not 1. Because if you multiply by 1, nothing changes. So it's not going to get bigger or smaller. So try to think about it that way. If it's bigger than 1, it's going to get bigger. If it's smaller than 1, it's going to get smaller. And if it's 1, then nothing's changing. Because if you multiply a number by 1, it doesn't change at all.
Okay.
All right. You're welcome. Okay, I'm going to give you an example, and I want you to figure out what the scale factor was. Okay, now I don't want anybody to say it out loud. I'm going to give you a second to type it into the comments if you have an idea. Remember, K is what we use for scale factor. So if I had the point, let's see. I'm going to start with this point, A, and it is going to be, let's go with 12, -4. And if I turned it in to A prime, and it became 3, -1. Don't shout it out loud, but I want you to figure out what scale factor could I multiply to get from 12 to 3 and from -4 to -1. You can type it in the comments if you think you've got the answer there. I'm seeing some good comments. I'll talk about it in a second. I want to see if anybody else can get it. Everybody's jumping on the 3 train. I'm going to tell you right now, it is not the answer 3. Multiply by 1/2. Dividing by 3. As you're giving these, I want to tell you what would happen. So if I took 12, and a couple of you said, one person said divide by 3. 12 divided by 3 does not give me 3. It gives me 4. So that doesn't work. Okay, someone said -3. So 12 times -3 does not give me 3. So if you just write down the number, for example, I see one that says -4. A couple of them that say -4. That means that I need to multiply by -4. That's not going to work here. Okay, Taylor gave a good one. Everybody look at what Taylor said. He said 1/3. That means you're multiplying by 1/3, but that still doesn't give me 3. That would give me 4. Because 1/3 of 12 is 4, not 3. I did see one of them that was correct. Oh wait, no, I didn't. Where is it? Williams is really close right there. Something with 4. That's good, Elijah. Trillion. Everybody look at trillions. There it is. Oh, it was on Taylor's too. I just didn't see it. 1/4. 1/4 is what happened. 12 times 1/4 gives you 3. -4 times 1/4 gives you -1. Now, that was kind of a tough one, I get. So let's try another one. Let's do one for B. Let's say that B started with, let's see. I'm going to go with 0, 2, and B prime is going to be 0, 8. I want you to figure out what scale factor I used to get from B to B prime. Nice, I'm seeing lots of the correct answer over in the comments. Multiply by 4, exactly. 0 is a fancy one because when you multiply by 4, absolutely nothing happens, wonderful. But 2, when you multiply by 4, gives you 8. So that, oh nice, good to see you, Makestri and Ava. Oh my goodness, I didn't even know you were here. I've kind of stopped keeping track of who's at the top here, but now I wanna look. Let's see, oh my goodness, Mason's here, Brooklyn's here. The whole gang. Just kidding. Lots of you though. All right. If you've got specific questions, add them to the side. If you don't know where you're at with the comments, go to the bottom and highlight where it says chat, and then you can turn on the chat feature. And I am trying to answer those questions as we go. If you missed the beginning, I'm going to post this online later. But I am now going to go over a couple questions that are going to be very similar on the test. Oh no, the color red is not a good choice. It does not erase well. This is like a really hard whiteboard to erase. I get like extremely like a big workout during this. Don't judge me. Okay. Let's do a group example. Oh. So here are some questions that are going to show up on the test, and they were on the flashcards that I put up today. So if we had this shape, let's go with A, B, C, and D. So if I started with that shape and I ended with D prime, B prime, C prime, and D prime. The question that I'm going to ask you on the test, is this an enlargement or is this a reduction? And I think I put the word neither on there as well. That's a trick question. Don't ever click neither. Well, I guess neither would be true if it didn't change size. But I want you to write into the comments, is this an enlargement or is this a reduction? Awesome, I'm seeing lots of people saying the word reduction. Exactly, okay? And that word reduction, shrink. If it gets smaller, it's a reduction. Now, if I drew another picture of the primes that was way bigger, then it would be an enlargement. The thing you need to look out for here, if you won't get to see me draw these, you are, oh, I'm not gonna use red because that's the hard one to erase. You are going to look, is there a prime on it? Because whichever one has a prime came second. And that's the big question. So if all you can see is these pictures and you ignore the labels, then you are likely going to get it wrong because you got a 50-50 chance that you're going to guess the wrong one as first. So I always kind of mentally go in and say, oh, this one does not have primes. It came first. This one has primes. Came second. Okay, we did that in class a lot. So mentally kind of get that. Look at all these people participating, saying reduction. Nice. All right. There are 2 problems on the test that look like that. And then there's one problem on the test that looks like this. Oh man. I was not making you feel this much.
What are you doing?
Really.
Oh my gosh.
Okay. I am going to give you a problem like this, and this is supposed to be like a really easy problem. I'm going to say, here's the rule. XY maps to 1/5 X, comma, 1/5 Y. And the only question that I'm going to ask you about this is I'm going to say, what is the scale factor?
Great.
I want you to see if you can answer that. What is the scale factor of this mapping? type it in the comments if you got it. They are not congruent, Rylan. They are similar.
Oh.
Shut the door, whoever's being told to shut the door.
Thank you.
I'll get water.
I think that the question is a little bit confusing, so I'll make it a little bit more clear. What's the scale factor? That means what is being multiplied. Taylor's got it. If you look over at the comments, that's all. Abby's got it. Now, those of you who are saying similar and congruent, that is another question I could ask you about this, but really all it's asking when it says what's the scale factor, it's saying what's being multiplied.
Away.
Stop talking.
I was holding that in for so long. I wasn't exactly sure. Thanks for the honesty, Taylor. But okay, the people who said similar and congruent, the reason this one's similar is because they both got multiplied by the same scale factor. Now, here's another question. Would this be an enlargement or would this be a reduction?
Ooh.
Nice, Julia. It is a reduction. Good job, Ava and Taylor, and William and Abby and all these people who are typing in reduction. How do we know that it's a reduction? What about that number 1/5 tells us that this is shrinking rather than growing? What do we know about the number 1/5? Okay, it's less than 1, it's a fraction. Or if it had been a decimal, then it's because it's a decimal. Because anything that's smaller than 1 is going to shrink, and anything that's bigger than 1 is going to enlarge. Okay, so keep an eye on that during the quiz. If it's bigger than 1, it's getting bigger. If it's smaller than 1, then it's getting smaller. And if it was 1, then it's going to stay congruent. It's not going to change size or shape. All right, I'm going to give you one more that I want you to look at. All right, I'm just going to give you 2 coordinates. And let's see.
Ouch.
Someone shout out a negative number.
-20.
-3.
-3. I like both.
-2.
Okay, so I'm going to say K equals -30. That's going to be your scale factor. And if you
Jason,
have
get out.
Jason, you should get out, or whoever she's talking to.
Yes, Jason, get out.
All right, I'm going to do A is at 0, 5.
Hi, Miss Johnson.
Jason, get out. Leave me alone.
Who is it?
My little brother, he's so annoying.
Oh.
Miss Johnson.
Hi,
Jason.
brother.
Hi, Miss Johnson.
Jason, she, oh my God, I have my AirPods and just get out. She's not gonna hear you.
I did hear him, but it's okay. You can tell him I didn't. So A is at 0, 5, and then I'll go with the number that Rylan gave us. B is going to be at, ooh, I'm going to give you
1.
Rylan said -20. If you get the number, blame Rylan. -20, comma,
Yeah.
2. Your job right now, I want you to dilate those coordinates. So write down what I'm going to put for A prime and B prime.
I shouldn't have said that.
I know you shouldn't have, Rylan. Great. We're all judging that now. I'm kidding, Rylan. It's a good one. So on your paper, you should be coming up with A prime, B prime. I'm going to show you how you should be writing it. A prime, you should have parentheses. B prime, you should have parentheses. Hi, Brooklyn. Why do you want to come down here? Just do it a little bit, okay? All right, if you've got it, you can type it into the comments. Got a couple answers. Just one. Just kidding. All right, so let's check out what Taylor's got there, and hopefully some of you have something similar. So he said A prime is at 0, -15. Let's check it out. If I do 0 times -3, that's 0. Perfect. And then if I do 5 times -3, -15. I had to think about that one for a second. Remember, Miss Johnson is not an all-star. -20. +60. By the way, if you're worried about the people in the background, you're always welcome to hover over your name. And then if you push the 3 buttons or whatever, you can mute yourself. Okay. negatives don't matter even though they're under 1? Really good question. I'll address that in 1 second, Taylor. And then 2 times -3 is -6. Taylor pointed out something really important that I kind of brushed over in a bad way. Negatives are under 1, and I told you that anything under 1 makes it smaller. That's not necessarily true. So I'm going to clarify based on Taylor's question. Anything that's a fraction or a decimal, anything that's under the absolute value of 1. So if it is between 0 and 1, it's going to get smaller. If it is larger than 1 or larger than -1 in the negative direction, then it's going to get bigger. Now, if that confused some of you, try not to focus on it too much, because the thing that I want to be able to tell the difference between is a whole number that's positive, making it larger, but also a fraction.
Oh my gosh, Malia, go away.
Don't worry, Brooklyn, I can mute your end. There you go. Okay. I think that was all I wanted to cover. So this is your chance to ask some questions. And Taylor, I hope that answered your question. If you have a question, did it freeze for anybody else?
No.
Okay, not for Rylan.
It didn't freeze for me.
Okay, not for Kate. If anybody's muted right now, like Brooklyn, I just muted you a second ago, but that's okay, Abby. It's a little laggy. Okay. If anybody has questions, ask them on the side, or you can also ask them out loud, unless you're muted, in which case you can unmute yourself and ask the question. Give you a second. I never know what to do while I'm waiting. Should I like serenade you or what? I don't know. Yes.
Miss Johnson, it's been such a long time since we've heard your singing.
You know,
Yes. Please
Happy
sing.
Bye.
please sing. How often will you do voice chats? That's a really good question. This was very helpful. Thank you. You're welcome, Julia.
Be
Sing.
safe, Dad.
Brilliant. So how often will we do these voice chats? How often do you guys want to do these voice chats?
We should do them
lot.
like
They're
every
like-
other day.
Yeah, they're easier than like reading stuff because a lot of times you get confused.
Okay, is this helpful?
Yes.
Miss Johnson's basement whiteboard? Okay.
Mm-hmm.
That's good feedback. At least 3 times a week. I can do that. This is easy for me. I just have to do one of them, and it was like an hour. So if you guys have an hour to spare, I'm totally fine doing these more often.
We should do our homeworks on Quizlet. Like we should.
Do you guys
just
like
do-
quizzes?
Yes.
I'm like worried that you're gonna start getting bored of quizzes.
No, like
No.
Quizlet. Like we should do our homework
Quizlet.
on there.
I don't know.
Yeah, like
I mean, I know what
I-
Quizlet is, but I've never made a quiz through it.
no, like yesterday how we did like the thingy on that.
Oh, that's called quizzes. And yes,
Quizzes.
your test is on quizzes tomorrow.
Yeah, we should do that because that's just funner.
30 minutes a day.
Is it a test or an assessment?
Good question. That's the same thing. Assessment is just the fancy teacher way of
Oh, okay. That makes sense. That makes sense.
The answer to that is no. The test will also be open book. You can look at anything you'd like during the test. I am not gonna like what can I do? Even if you want to like look through all of your notes that you've ever taken, great. Then you'll learn something. I'm not sure what that question means, William. Up. Let's see. Oh, Abby, I actually know what's going on now. I'm glad to hear that. I hope that everybody else who watches this can get some stuff from it too.
This is way easier now.
If you felt like you understood this, then I really think that you are going to do well on tomorrow's test. And I'll answer that question again. It is not timed. It is not timed. You can take as long as you need. I'm glad that your brain is growing, Bronson. Actually, that's probably not a good thing. Your brain should just be getting better. Let's not let it grow. What do you need to grow? Yeah, the stapler's right next to the lamp up there. Just in case you're all wondering, my stapler is by my lamp.
Yeah, does your daughter like your stapler a lot? Does she use it a lot?
I don't know, probably. Oh yeah, because she came and grabbed it during
Yeah.
Just to be fair, the only 2 times she's needed my stapler were like the 2 times I've filmed. Any other worries and concerns about the test? I'm loving these singing requests. Any other worries? Any other concerns? I hope you're feeling a lot more confident for tomorrow's test. And if it makes you feel better, tomorrow's test, it's not the same unless you think about the test. Tomorrow's test is all you have to do tomorrow. You have no homework tomorrow, just the test. So if you can do that, then you have no more homework for the whole weekend. Yay! And what we're going to keep doing is we are going to have short ideas, one idea each day. If it gets overwhelming, reach out, let me know, and we will try to make it less scary. But if you can keep track of that short thing each day, you'll be good. We're not going to do huge things and then test on all of it. We're going to try to keep it short ideas that we test on.
Bro, be quiet.
So you're going to see more tests, but it's going to be shorter. All right. I love you all so much. I miss you already. I hope you have a good job or a good experience doing your test tomorrow, and we will see you Monday. I'll try to plan another one of these early next week, probably like Monday or Tuesday, and I will see your beautiful black screens that, oh look, someone's face showed up. Makestri, finally.
Hi, Miss Johnson.
You are faceless. It's good to see you, Makestri.
You too.
You're welcome, Trillion. All right, I'm going to end this session. We'll see you all on Monday. Bye.
Bye, Miss Johnson. Bye.
Bye.
Ending the